we are looking at, I'm looking at putting together a small assignment, similar and different than another one that we'll do next week. But dealing with XML should be small, should be a little bit more complicated than the last one, which was the conversion process, which I think you guys said, oh yeah, this took like 5 minutes to do. Like, okay, it's going to be a little bit harder than that. So it'll be a little bit more of a challenge than that, but still should be pretty simple. At least I'm hoping so. All right, so let's talk about what we kind of really want to talk about today, which is it's, by the way, it's in your textbook. I don't know if you've gone and checked it out much recently. It's under the extract, transform, and load section. It's a subsection there just on XML data. So I spent a good chunk of last week and last night writing and editing and tweaking and going back and throwing out half of it and starting over. And XML is kind of an interesting thing, and it's also very chicken and egg-ish. It's like, which one comes first? How do you talk about XML without talking about XML? And so how do you kind of put it into the right context and how it's used and why you're using it and stuff like that? So this section was actually a lot more challenging to write than I thought it would be. Which is part of the reason why I haven't broken it down to notes yet. I hope to do that soon, but if not, you still have the book you all have access to, and you can see it there. So let's talk about XML and what it is and why it is and why I put it with the extract, transform, and load section. So if we go back to what we were thinking about previously with extracting data, transforming it, changing it, which you kind of did with that Roman numeral project, and then loading it to another thing. We have throughout this whole process of how do we get the data from system A to system B. And there's been lots of different ways that we have, in theory, tried to do it over the years. And this can be because we might get a nightly data dump from a system. It could be because we're migrating from one system to another, or we might be trying to have what they call interoperability, which is I'm working on a medical records program, but I want to make sure I save my data in a standard format that everyone can be able to reference and read. That way they can bring their data in and do something different. If, like, I have medical data, but they do billing stuff for medical records, they need to understand the medical records so that they can bring in the billing part. Okay, does that kind of make sense, of why we want to move that data from one system to another? So how do we do that? We want to have something that's simple, that's easy to use, in a format that we can do. Over the years, we've done things like comma delimited files, or flat files, or databases, or just kind of a variety of different things that we've done. The problem is a lot of times those types of files aren't necessarily really descriptive. It doesn't tell you what this information is about. And if I get extra data or some data is left out of it, I start to have problems being able to read it. Additionally, I might have a situation where I have complex data. So I've got a object over here, a patient, and a patient has a procedure object. And now I have a relationship which is harder to describe with a flat file, like a comma separated value file or something like that. I can do it in databases, but then I have to know how I'm linked and structured together to have related tables and make sure I'm bringing in that table. And can I parse between two tables? moving data from one SQL server to another SQL server, or one MySQL to another MySQL server, that's pretty easy. But if I got to move data from Oracle to MySQL, or if I need to move from IBM DB2 to another one, that can be a little bit more of a challenge, because those don't always line up the way you think they should. Um, Maybe they have their own custom data format. Oracle is notorious for that. You guys have gone through database class. You're familiar with varchar. Oracle has varchar 2. Yeah. Uh, why? Just because they could. And they had some reasons behind the scenes for it, but it just isn't really, really easy. So an idea came out in the mid to late 90s, if I remember correctly, called XML. And XML stands for Extensible Markup Language, and it was designed to be a plain text file that was self-descriptive. That means that you could, as you read the file, you didn't just see numbers and text and stuff like that. It was surrounded by it's given name, and so you knew what this field was supposed to be. And it helped you kind of get some ideas about how to treat these fields and stuff like that. Because of its format and the way it was structured, you're supposed to be able to ignore certain nodes or children, or look for them. It kind of goes back and forth. You have some options. And if someone adds additional information to it, you should be able to just flat out ignore it. And so it should, keyword should, simplify the process of moving data from one system to another, because I can look at its names, I can know what it is, I can match it with fields in my system, because I should have some idea about what and how that data is stored. And if there's a change, maybe I throw a message so my developers know to look for it and how to handle that change in a file format, but I should not break what I have already created. Okay, there's a lot of shoulds and woulds and coulds in there. I don't know if you caught them all. There must have been a dozen or more. And that's going to be one of the key components when we look later on at some of the problems with XML and why it doesn't always work out as good as it should. Keep those all in mind, because we're going to come back to them. Okay. So this is a basic idea behind XML. And if the developer can know how it kind of works internally, they can be able to convert it to their internal format, use it. And so XML got used a lot, and especially as it came out as the internet started to become really popular at mid to late 90s timeframe. XML was used for sending data back and forth. If you want to process a credit card company or a credit card, you send it to a credit card processing company, and you send all that data as an XML packet usually. If you want to upload a product catalog to an online system, they usually want it as an XML file, and they'll give you the general specifications so you know what to call product SKUs and product names and all that type of stuff. But you had that flexibility, at least some flexibility to make it work. And so XML was used for that. XML was just used all over the place. And so that became good. A lot of people understood how to write XML, which was kind of nice because it was straightforward. It was self-descriptive, and there's a lot of good stuff. It looked very familiar to HTML. And once again, because the internet was starting to boom at this time, everyone knew HTML, and so everyone who knew HTML went, well, if I know HTML and I can know XML really easy. The problem is that just because something looks like one thing doesn't mean it is like that one. A perfect example is if I look at the name Java and look at the name JavaScript, you would assume, well, they both have Java in them, so they're related. And there's a whole series of jokes and memes online about how Java is not related to JavaScript at all. It's kind of like, Java is related to JavaScript as pencil is related to penicillin. Okay, just because they have similar names does not mean they do the same thing, they work the same way, or anything of that sort. And so people make kind of this false assumption that, well, if I know HTML, I can know XML, and that'll be easy. One of the big differences is that HTML was designed to be viewed by an end user. HTML's purpose is to be consumed by end users. This is not true of XML. XML just sits there and does nothing. And nothing is a kind way of saying it. Let me pull open. Oops, I don't. Aha, here we go. I thought I still had it. Okay, here is an XML file. Here's what it looks like when it's viewed inside a browser. Most browsers can handle XML. This is an example of what XML looks like. You go, ew, this isn't pretty at all. And you're absolutely correct. It is just raw data. And you can kind of look at it and start to go, oh, I see how this is organized, kind of. Why are they doing it like that? That's kind of weird. But you can. You have a cube here, you have a cube here, and you have a cube here. Why do you have three elements that are children of one another, all with the same name? I don't know. I don't know. That's weird. Okay, so you have this self-descriptive file. Sometimes the descriptions are better than others, but it is not HTML. Now, one of the things that you can do is you can add in something that looks kind of like an HTML tag, which is the XML versioning tag. And this just lets you know that, hey, I am using XML version 1.0, I'm encoding using UTF-8, and it gives some stuff. This is actually an optional tag. If it does exist, it needs to be the very first line. I used the system once, and we foolishly had a blank line, and then we had this line of text. And we said, oh, it'll work because it's there, right? Turns out it would not work. And not only did it not work, it failed in a most glorious and brilliant way possible. Big error messages just everywhere you turn. Why? Because the first line was not that XML versioning line. Now, like I said, it is by this specification technically optional. However, big however, sometimes the file parser that you're using or that a end client is using, they will want to see it. So I generally recommend including it just to be safe. That's a big thing. Your encoding does not have to be UTF-8. UTF-8 is standard Greco style keyboard with the English language and stuff like that. There's other forms of UTF like UTF-10, which gives you additional characters that you sometimes find in other languages. Things like where you have an umlaut, which is those two little dots over a vowel, or little accent marks, or other things like that. So if you're going to use another language, or you're going to be having data that's translated from another language, you may want to use a different version of UTF-8 other than UTF-8. If you don't specify it, most of the XML file parsers will assume that you're using UTF-8. So just kind of keep that in mind. This, like I said, is kind of similar to a doc type tag that you might find in HTML. And the whole idea is we just want to make sure people know who's reading it, what it is that they're reading. And that's the reason why some parsers make it required. Okay. Now, if you remember, we talked earlier about a tree structure. And we said how trees have nodes, and those nodes can have nodes, and you can have multiple nodes from there. Well, that is essentially how an XML document is written. It is completely written up on a series of nodes. And these nodes are standalone. They have a hierarchy, but you cannot other than like saying this is a sibling of mine, we're on the same level, or this is a child of mine, or this is a parent of mine. I can't have really relationships within these nodes. It's not like I can say, here's a list of actors in Hollywood, and here's a list of movies, and then create a relationship and say, well, this actor was in this movie, and this movie starred this actor, and back and forth. I can't do that. That's not how that part works. I can't relate stuff. I can only relate it as if it was a child node or a parent node type of setup. This does make some things break down where I can't either I can't display the data, or the data gets so large and so complex so fast that I essentially can't do it. If you go back to one of the things we talked about before with the 6 degrees of separation with the Kevin Bacon game, one of the things we talked about is, okay, we want to find all the movies that Kevin Bacon was in, and then find all the actors who were in those movies, and then we have to find all the movies that they were in, and then find all of the actors who were in those movies. And so very quickly, because Kevin Bacon's been in so many movies to begin with, and some of the people he's been in with have been in lots and lots of movies. That's how you can make those connections so quickly and easily. Because of that, finding every actor or actress who's been in Hollywood within 6 degrees of working with Kevin Bacon gets to be very large, very fast. And that causes problems. So you just got to be really careful with that. In addition to your node, or if you might think of it as like a tag, if you're thinking of it as HTML, you can also have attributes that can assign and describe that tag. Not only can your nodes have child nodes or child tags if you prefer, and they can have attributes, they can actually hold data themselves. If you come back here to this example, we have this tag called subject. We won't worry about what's on the front side of that colon just yet. We'll talk about that in a little bit. We're just going to look at the back half of the colon. So it's called subject, and this has reference rates. Reference rates is the inner text. It is the content of the subject tag. Sender has a child tag called name, but name then has a value, an inner text of value. On the other hand, cube, as a child of cube, which has children of cubes, notice that they do not have any inner text. In fact, these are what you refer to as self-closing tags. So in XML, every tag has to be closed. If you open it, you must close it. The only exception is that doc type of tag at the very beginning. Every other tag, if it opens, it must be closed. If you look at these, however, you notice that in some of them you only have the open ones, like these cubes, and that's because it has the currency and the rate, and then it stops with that backslash. So this is called a self-closing tag. You must have a main node, and then from there you'll have children nodes. So I can't have my XML doc and then have 3 sets of nodes. Okay, I can't have nodes for books, movies, and music. I have to have a node that's called My Collection, and inside My Collection, I can have books, movies, and music. But I cannot have it where I have essentially 3 root nodes. So the idea is that I have one main root node that everything else branches down from. If you think about this as far as like an HTML file, you have an HTML tag. It's your very first tag, and then its closing tag is on usually the last line. The idea is that all of my other tags extend from this one root tag. And that's the same way it is with XML. It just makes it kind of work a little bit easier as far as how that gets processed. Generally, and this is just a naming convention, it's not a requirement. I like to use it myself, but if I'm going to be a collection of other tags, I like to name that tag with a positive, or not positive, but a plural name. So if I'm going to have a collection of books, I'm going to call it books. Why? Because it's plural. It lets me know that I'm going to have multiple children to look at down the line and how it works. And you can kind of see this as an example here. Books has a book element, and then they have subtags or sub children or sub tags, one for title, one for author, and one for edition. However, there's no requirement that I do it like that. I can also use attributes. So I can have books, and I have a book here. I have a title attribute, an author attribute, and an edition attribute. You might say, well, why would I use one instead of the other? Are they exactly the same? No, they're not exactly the same. Consider a book which has multiple authors, just as an example. A book that has multiple authors, I might want to use an author tag set and just list those additional authors. It makes it easier to go in and list multiple values. If it's an attribute, I can only have one value for one attribute. And so if I only have one name or one author in this case, then it makes sense to use the attribute. If I have multiple authors, then I have to use the tags. Now, we won't generally have multiple titles for the same book, multiple editions we might have. So you just have to kind of see what type of information do I need. Am I looking at a personal library where I only care about what edition I have? Or is this, the public library or the university library is going to have a lot of the same book? There are a few book titles that or titles that you'll find that's released as one title in this section, one title in that section. But we're not trying to look at those kind of one-off weird examples in a case like this. Okay. But in these two examples, as you see, you can see that they provide basically the same information. It's just a matter of how are we going to access it. Are we going to use a accessor method, which is going to access the attribute, or are we going to use a tag method where we're going to access those tags? We just kind of need to know between them. Okay. If I only use the attributes, then I can use this closing tag. Alternatively, and I'll just copy and paste this so you can kind of see what it would look like. If I don't have a self-closing tag, I have to have a closing tag, and that is technically correct. It's not logical, but it does technically work. Now, a couple of really good things about XML is because XML is such a loose specification. It was not designed to move data specifically from one section to another. XML itself is very, very loose. Because of that, a lot of programming languages have libraries for them that you can either download, install, and use, or they come with the programming language itself. In fact, many come with the programming language itself. Now, it doesn't mean that there's not a better library out there to use, but you can go in and use them. In fact, some languages provide multiple libraries. Just kind of depends upon what you're doing. A perfect example of this is C# actually has two different methods. One lets you download and load into memory the entire XML data structure. Makes it very fast for accessing, but consumes a lot of resources, especially for large XML files. You got to load that all up in memory. You got to parse it all out before you can do anything. Once you're in, though, it starts working really quick. Others kind of parse as you need them, and they open a file and then they kind of essentially kind of like put a bookmarker in, close the file out. Oh, I need it again. Open it up, read what I want to read, put a bookmark in, close it up, and I open and close. And that's not as fast, but it doesn't consume all of my memory and processor processing and all that type of stuff. So just kind of depends upon what's best for the process that you're doing. Knowing what you're going to be working with is a huge, huge thing to keep track of. So just kind of keep track of that. Now, while each library is going to be a little bit different, they're also going to be very similar. So you're going to have methods that, and while they may not go by these specific names, you'll find something similar a lot of times. Something like get child or get next, or maybe get previous that allow you, get next and previous allow you to work with siblings. Child obviously lets you get a child, and sometimes it's like get first child or get children, or like I said, you're going to find some slightly different names depending upon the library you use. Be able to get an attribute or a value or parent; those all matter as well. You can, if you want to, with them, reference them by number. So, you might say like get children dot get current child 3, and it's okay. So I'm getting child, I'm getting my grandchild, and then I'm moving over to my third or fourth element, depending upon if I'm 0 index or 1 index system. So how you move through them can be up to you. Now, I specify, in that example where I said, okay, get element 4, which gets me my fifth element typically, but I could also use something like xquery, which allows me to query based upon names and get result sets from there if I want to. So here's an example. XML doc is the object in this case that was created. Document element was that first outer level tag that was used. Then it gets the child nodes, third one. Remember, we start at 0, so 0, 1, 2, so third element. Then get its child's nodes, the first element, and then get all of those child nodes. And that can be actually found in a simple little tutorial I'll show you right now. So let me. Oops, that was not the one I want to do. Okay. So here, pulling in that XML file that we did earlier. Okay, so we talked about that. Here I say XML node. This comes out my XML document. I load my XML document. That is here is XML doc. I load it from an external source. I say for each XML node, which is a data type in system.xml. And then I say, okay, document element. That's my first overarching node, then child nodes 2, then child node 0, then child nodes, and that gets me every one of them. Because that's every one of them, I can use a for each loop, so I'm going to iterate over those nodes, and I'm going to print out, notice once I get that node, that's several layers deep, I'm going to get my currency value and my value for my rate attribute. So I've got a couple different ways to do it. In this case, I am referencing by um, an index number. In this case, I am referencing by a name. So sometimes you can intermix them, sometimes you can't. You just kind of have to depend upon what you're using. If I parse this out, I should list my currency, space, and then the rate. The currency is going to be actually probably things like what country it's coming from. The rate is the currency conversion. So if I come here and process it, give it a minute, there we go. You can see how it processes different things along the way. They're not doing USD as the base source. That's okay. So that's kind of how that particular library works. We are going to look a lot more into detail on that on Thursday. So if you're going, wait, hold on, I need to see this. Don't worry, on Thursday, we're going to talk a lot about that. The biggest problem with using a indexing type of node system like this is, what if the XML file gets changed? The format changes. Now, in theory, there should be ways to handle this. If I'm using names, then it's really easy. But if I'm not, then it can be a real challenge. And those are things you got to keep thinking about when you're working with it. That's one of the reasons why XQuery is real popular, is because you can reference something by its name, and because it's self-descriptive, the name is right there. I know this, as long as I don't do something like name 3 levels all cubed, which is kind of weird. All right, let's talk about some common issues people have with XML files, though, however. Because it was designed to be the be-all, end-all of data formatting, transfer of information. This was going to solve all the world's problems. And if we just all jumped on XML, we wouldn't have any issues. But there were some real big issues. Number one I found is what I like to call strict implementation. There was a site, I've mentioned it before. I can't remember if I mentioned this class or not. But when I was transferring data via XML to their server, they wanted it so specific. You know, they wanted tags even if the tags weren't used, and that caused some real issues. We had like 15 tags that weren't used, that had to be put in the middle of it for some reason. It was the way they were parsing it. They were expecting to see those nodes. So that strict implementation of saying this is our format, this is what we're going to use, this is what you have to provide, that sometimes is a problem. So kind of keep that in mind. One of the biggest complaints about XML is what they call unnecessary overhead. This is all about, you know, if you have to load multiple files or really big files, this is when it starts to become a problem. Moving between the data in those files, that's okay. And sometimes have a lot of data, so that's why it's large. But large XML files tend to really slow down a boat or a ship or something like that, or any other type of large application as it moves that data, and you're trying to load all up into memory storage space. So what I'm talking about the ship is, let's say I had all of my shipping inventory and I have a container ship that's used for cargo, and I want to load all my inventory. Well, on a ship, I might not have super fast computers, and I can't just run down to the store and get me a new one to be able to handle it. So I could have a lot of overhead that slows down my ability to process this file. And if I can't process this file easily, I may not be able to now start moving towards my final destination where I need to. And so this can cause issues. It could also cause some issues with wasted bandwidth. Um, Part of that is, if you look at it, I've got 2 tags for everything, just about. Sometimes, and this is actually pretty common, the data being stored in the XML file takes up less space than the tags for the XML file. Um, so when I have a situation like that, that's a bad situation. We don't want that. So we have to be very careful of um, that overhead and how it's used, as well as our performance, because um, if we don't design our XML files right, we can really hurt ourselves with both of them. Um, Now, one solution, and the overhead and performance issue is not just in reading, but can also be in writing. Um, and so one solution to that, especially if I have a file that's real popular, a lot of people are downloading, is that I will go in and create a file on a schedule. So I'll say, okay, you know what, every X number of minutes or X number of hours or once a day at 3 o'clock in the morning when no one else is on the system, because let's face it, how many people are working at 3 a.m. in the morning? I might then go in and create that file to be downloaded or processed or whatever. And when that file is processed, then it will um, be stored as like a cached version. And so you can actually download it. You don't have to regenerate it. Uh, Perfect example of this is we had a file that every time it was generated, it took like 45 seconds to a minute to generate. Well, no one wanted to click on a file and to wait to download this really big file that took a long time to generate. So we just generated it like once a week or once a day, kind of depending upon how often your data changes. We just did it that way, and then it processed. It took its 45 seconds to 60 seconds. It got copied to a flat file. People were just able to download that directly instead of having to try to go in and recalculate everything so often. Another problem that you can run into is special characters. Obviously, when you are using tags, you don't want to say, oh, is this a tag within a tag or is this part of my data? So if I need to have data that has angle brackets in it, or data that has the ampersand symbol or equal symbol or something like that, I'll have to specially encode those so that they can be processed and used. It's not a big issue, especially if I'm using an XML parser, because a lot of times they'll say, oh, wait a second, this is all the data you're giving me, but this doesn't look right, let me fix this. On the other hand, in other places, it can be a real problem. So we have to kind of keep that in mind as we're working with our XML files as well. Okay. Any questions with the XML data at any point? Are you all there, or did my machine freeze?
I'm here.
Okay. I was starting to get scared there for a second. Um, So I know it's a lot to take in. It's really, really quite simple in a lot of ways. Some of the things that make XML difficult is the add-ons, things like XQuery or XSTLs, which is like a style sheet for XML. Um, so it's very easy to learn, but it's kind of like chess. It's really hard to master. You know, they say you can learn how to play chess in an hour, but in 10,000 hours, you still haven't mastered it. Um, that's kind of the way XML is, I find. The key thing is to test, and see what you can do from there. If you do that, then it winds up being okay. Usually is a key term there. So just kind of keep that in mind, if you would, as you're processing all these different things and what you're working on with them. Next week, or sorry, not next week, next class on Thursday, we will actually start to look at how do we want to go in and build an XML parser ourselves, or not build a parser, but use one of the XML parsers in C# ourselves. Kind of like, oops, kind of like what I did here, but with some additional nodes and examples and stuff. And we'll just do like a little in-class assignment, or it should be done kind of in class. So that's what we're going to be doing on Thursday. So then we go from there. I hope to have the rest of your assignments and stuff graded this week. I'm a little bit behind with everything going on. But they should be graded this week and all caught up there. That's knock on wood. My goals for this class. And then we will be all ready to go. And then next week, we will look at JSON data, which is a JavaScript object notation, which is designed to solve some of these problems that we have in XML. So knock on wood, but that's where we're going with it. Okay. Any questions?
No, I'm good.
Okay. Well, that's all I have for today. We're done a little bit early.